Hey, Greta. We'll wait a few minutes for everybody to get on. I'm sorry, I have a cold too. Hey, Mackenzie. We're just gonna wait a few minutes. And Kirsten, good morning. How's everybody doing? I, for one, have a lovely cold, so it's going to be fun to listen to me today. So you all should be glad that you are online and not in person with me. Or maybe you're sad that you're not in person. Maybe I would have had to cancel class because I feel I'm like, bleh. All right, I'll give everybody like one more minute and then we'll get started. Anybody have any questions they wanted to go over? There should be a chat. Can you guys all get to the chat? The random chat. Let's see. Well, that's not very exciting. Smiley face. And if you hear my mic cut out, that's probably me just trying to block you guys from hearing me cough. All right, Mackenzie and Kirsten, can you guys hear me okay? I just want to make sure before I start. Oh, I wonder if Kirsten's on her phone and she can't chat in there or something like that. Maybe. Okay. Oh, look at that. You just texted me. Perfect. I remember you saying that from last week. Okay. Well, the good news is I think that we're actually recording it so that the people that are missing can actually watch it because Google Hangouts was working, but I wasn't able to record it. So now we should be able to record it. Hey, Olivia. Of course, that's not good if you can't ask me questions. So I don't know. Yes. So I'm glad everybody's here. We're going to go ahead and get started. Again, I apologize if I cough in your ear and sound yucky. It's better than me being in person. And class will probably be a little bit shorter today because I don't know how long my voice will hold out. Excuse me. Okay. All right, let's get started. I'm glad everybody's here on what day was it? Monday. Monday. We talked about special right triangles, and I think oh, hey Jake. I think Greta and Kirsten said that some of these were on the ACT, so good thing to know. So just to review, we talked about both of these in class, but I think it's good to actually do some problems with them. And you guys said that it was easy peasy, so we always like that, right? Okay, so the first thing that we have is a 40-40, 45-45-90 triangle. So this is a triangle where we have two sides that are the same. They're isosceles. And then we have the hypotenuse side. So we have 45 and 45 degrees. So I know that we kind of proved this on Monday, but anytime that you have a 45-45-90 triangle, the hypotenuse is the square root of 2 times as long as each leg. So the hypotenuse equals the leg times the square root of 2. This works for every 45-45-90 triangle. It's always true, and that has to do with the Pythagorean theorem, right? Because these two sides are the same, and this is always going to be true. Hi, Sophia. Somebody at Sophia's house is not happy that they have to do geometry.
It's 10:04.
I can hear you, Sophia.
10:04. 10:04? Yes.
Okay, it's only 10 o'clock.
Hey, Sophia, I'm going to mute you, not because I don't like you, but I'm going to, let's see. I'm going to mute you because I hear a cute baby in the background. Okay. So 45-45-90 triangle, always true. We talked about why with Pythagoras. He kind of proved that was true on Monday. So the problems that we have to do this were actually really pretty easy. So example 1A, we have a triangle. It is a right triangle. One of the angles is 45 degrees. So if this is 90, this is 45 degrees. This also has to be 45 degrees, right? And if these are both 45 degrees and this side is length 6, then this side also has to be length 6. Okay. And so if this is 6, 6, then this is 6 times the square root of 2. And we know that because the hypotenuse equals the leg times the square root of 2. If you completely forget it, you can still use Pythagoras, okay? And we could say this side over here, which is x, right? X squared equals 6 squared plus 6 squared. And that means that x equals basically 2 times 36 square root. Or x equals 6 times the square root of 2. So it's kind of nice, easy to remember this rule. Then you don't have to do Pythagoras every time. But Pythagoras still works even if you don't remember him. Okay. So then what about over here? We have this triangle. We have two sides. One is 4 times the square root of 2. One is 4 times the square root of 2. And we have a right angle. It doesn't actually tell us what these two angles are. But do we know that they're 45 degrees? We do know they're 45 degrees, right? Because since the sides are equal to each other, that means the angles have to be equal to each other. And the angles have to add up to 90, so these both have to be 45 degrees. So since they're both 45, then I can use my rule that says my hypotenuse, my long side, right? My hypotenuse equals my legs times the square root of 2. So my hypotenuse here equals 4 times the square root of 2 times the square root of 2. So here's kind of busting out your square root skills, right? What is the square root of 2 times the square root of 2? It's just 2. The square root of 2 times the square root of 2 is 2. So this is like 4 times 2, which is 8. So the hypotenuse, oh, that's a terrible 8. The hypotenuse of this triangle will be 8. Okay. And then what about example number 2? So these are all 3 different cases, but kind of the same way. Example number 2, we have the hypotenuse. They tell us the hypotenuse is 9 square root of 2. And we have these other 2 sides are x and x. Okay, and this is 90 degrees. If these 2 sides are equal, that means that these 2 angles have to be congruent to each other. And that means that they have to both be 45 degrees. So we're allowed to use this theorem because they're both 45 degrees. And we know that the hypotenuse equals the leg times 2. So the hypotenuse, oh, that's that one. The hypotenuse equals the leg times the square root of 2, right? Well, in this case, they've given us the hypotenuse. They tell us the hypotenuse is 9 times the square root of 2, and that equals the leg times the square root of 2. So we just need to divide both sides by the square root of 2. And we find that the leg is 9, right? So x is 9, x is 9. Any questions about that? That's the easy peasy one, right? It is a popular question on tests and that kind of thing. So not a bad thing to remember. There's a couple more examples here, but I think you guys probably have it. Okay, so this was the other one that we talked about. This one isn't quite as intuitive. Like it takes a little more work to memorize, but you guys can still totally do it. Okay. So this is a 30, 60, 90 triangle. So before we had a 45, 45, 90. So the 2 sides were the same. This is a little bit different, but it's also a very common triangle, 30, 60, 90. So in a 30, 60, 90 triangle, the hypotenuse is 2 times as long as the shorter leg, and the longer leg is square root of 3 times as long as the shorter leg. So the hypotenuse equals 2 times the shorter leg, and the longer leg equals the shorter leg times square root of 3. Okay, so again, this just has to do with proportions of the sides, and this again is something that's always true for 30, 60, 90 triangles. So let's try some examples with this, okay? Yep. Let me pull this one first. I hear you. Okay. So we have this triangle here. Find the values of x and y. Write your answer in simple radical form. So what they're saying when they say simplest radical form, this the square root sign is, oh, that's not what I meant to do. Also not what I meant to do. All right, there we go. This word radical in math indicates like a square root sign. So if you see radical form, that means they want you to leave it in square root because, I mean, you could just say that what the decimal number is, but we want you to leave it in radical form. Okay, so a lot of times we do that even in upper level math. So it's kind of getting used to that because it's a more precise version of the number than just the decimal. All right, so we need to find x and y. We have a 30, 60, 90 triangle, and they give us 8. Okay, 8 is actually our longer side. This is our longer side. How do I know that 8 is my longer side? Well, one, I looked at my picture, right? But I'm not always going to have a picture. So how do I know which one is my longer side? I know it's my longer side because it's across from my bigger angle. That was supposed to be a straight arrow there. So 8 is across from 60 degrees, which is bigger than 30 degrees. So 30 degrees is across from x, right? And that's my smaller side. And 8 is across from 60 degrees with my little bit bigger angle. So this is going to be my larger side. Okay. So now that we've established that 8 is my longer side, then I need to use my formulas here to figure out what the shorter leg and my hypotenuse are. So this is going to involve a little bit of review about radicals too. So we know that the longer leg, longer side or longer leg is equal to the shorter leg times the square root of 3. Okay. X is my shorter side. So if I fill in my blanks, I have 8 equals x times the square root of 3. So if I want to solve for x, then I need to divide both sides by the square root of 3. Okay. So I end up with x equals 8 divided by the square root of 3, which is technically correct. That is technically a correct answer. However, in math, we do not like to put radicals in the denominator. It's kind of like one of those big no-nos in math. Never put a radical in the denominator. So we actually need to change. It's kind of like writing an improper fraction, right? Although those aren't too terrible, but this is an even bigger no-no. So we need to get that radical out of the bottom. And so this is kind of the new part. This is where you kind of need to figure out how to do it. And especially if you're checking your solutions in the back, they're not going to write it like 8 divided by the square root of 3. So in order to get a square root out of the denominator, what you have to do is you have to multiply by whatever radical you have. So I'm going to multiply this whole thing by the square root of 3 over the square root of 3, which is just like multiplying by 1, right? So we're allowed to do it. But what this does, when you multiply, you end up on the top with 8 times the square root of 3. And the bottom, the square root of 3 times the square root of 3 is 3. So this would be the proper way to write what the length of side x is. Okay? Just to kind of prove it to you, in case you didn't believe me. If I do 8 divided by the square root of 3, okay, and I do 8 times the square root of 3, not 30, divided by 3, you see that you end up with the same number. So these two are the same exact number. This is just written in an improper way, and this is the proper way to write radical numbers. Okay? So just know, and that's not just for this section. This is any math book. Anytime you have radicals, you can't have a radical on the bottom. All right, so that was a long explanation to get to what x is. So x, we just figured out, equals 8 square root of 3 over 3, floating 8 there, okay? Now, we got to figure out what y is. Y is our hypotenuse, right? So, back up here, we know the hypotenuse equals 2 times the shorter leg. So the hypotenuse equals 2 times the shorter leg. So the hypotenuse is y, 2, and then the shorter leg, we just figured out 2 times 8 square root of 3 over 3. So the hypotenuse would actually be 16 times the square root of 3 divided by 3. And that would be the answer in radical form. So a little bit more tricky, right? Because we're dealing with radicals, but nothing that you guys can't do. Any questions about that? All right, so let's do some more examples then with the 30, 60, 90 triangle. And I think we have some real world examples. Oh, we should have probably started with one of these. Probably would have been a little bit easier. I went right to the hard one for you guys. So if you got that, then the other ones are going to be easy. Okay. Okay, you make a guitar pick. You guys know what a guitar pick is? Yeah, guitar pick, right? You make a guitar pick that resembles an equilateral triangle. So equilateral triangle means all sides are the same. And the side lengths are 32 millimeters. So we have 32, 32, and this bottom part is 32 as well, if you add 16 and 16 together. What is the approximate height of the pick? So they've actually drawn a nice picture for you, right? They made this guitar pick, and it's an equilateral triangle, so all the sides are the same. And we also know about equilateral triangles that the angles are 60, 60, and 60. So you see they marked here that this is 60, this is 60, okay? And this top angle is also 60, but we're dividing it in half because we want to try to find the height. So if we divide 60 in half, then one of these angles is going to be 30 degrees. And all of a sudden, we divided our equilateral triangle in half, and we've come up with a 30, 60, 90 triangle. Right? 30, 60, 90 triangle. Okay? And we want to find the height of our triangle. So you'll see here it says, draw the equilateral triangle as described. Its altitude, this altitude, forms the longer leg of two 30, 60, 90 triangles, right? 30, 60, 90 triangles. So by dividing it in half, we get 2 30, 60, 90 triangles. The length h of the altitude is approximately the height of the pick. So the longer leg equals the shorter leg times square root of 3, right? The longer leg equals the shorter leg times the square root of 3. We have that from our notes. The longer leg here is h. So h equals the shorter leg, which is 16, times the square root of 3. Hold on just a second. Yeah. Yeah. Oh, sorry. My brain for a moment for my cold. Okay. The longer leg equals the shorter leg times the square root of 3. We're good. I was having a moment like, that's not right. But that is right. So the longer leg is 16 times the square root of 3, which if you do the math is 27.7. 27.7 millimeters. So does that seem right that the height of the pick is about 27.7 millimeters? Yeah, that seems right? Because our sides are 32. So it's reasonable. It's not, unreasonable to expect that. Okay, let's do another exciting example. Got some windshield wipers. Okay. Windshield wipers. A car is turned off while the windshield wipers are moving. So if any of you drive, you've known this. You turn off your car while the windshield wipers are going, and they just stop up on the not the dash. What is that called? Your windshield. So our windshield wipers got stuck up on our car because we turned it off. The windshield wipers are 24 inches. So we can see they're 24 inches long. And somehow we've stopped them so that they form a perfect 60-degree angle with the bottom of the car. So we want to know how far from the bottom of the windshield are the ends of the wipers. I know you guys were super curious about that when you stopped your windshield wipers, right? So I'm going to make a bigger windshield here. Okay. And we know that our wipers are 24 inches long. Okay. Somehow we've managed to perfectly stop our wipers so that they're at a 60-degree angle. Voila. Ta-da. Okay. And we want to find how far from the bottom of the windshield, so this is the bottom of the windshield, to the end of the wiper. We want to find this value over here. Okay. And this value, this x, is actually our longer side. So I'm going to call that L for our longer side. Okay. And I know it's the longer side because it's the value that's across from 60. And then I have one more angle, which is 30 degrees. And this is my shorter side. Okay. So we need to solve for the larger side. In order to solve for the larger side, let's actually figure out the shorter side because that's really easy. So if you remember your formula, the hypotenuse equals 2 times the shorter side. So our hypotenuse is 24 inches, and it's 2 times the shorter side. So that means our shorter side is 12 inches. That's really easy. We like that, right? So let's say our shorter side is 12 inches. Now, we have to figure out the longer side. It's nice that we found the shorter side, but we got to figure out the longer side, right? Okay, so the longer side, if you remember, is equal to the shorter side times the square root of 3. And we just figured out that the shorter side is 12. So the longer side is 12 times the square root of 3. So the distance from the bottom of the car, to the top of the windshield wipers is 12 times the square root of 3. If we wanted to know what that is in a numeric form, so this is the radical form that we were talking about. If I want to know what the number for that is, it would be 12 times the square root of 3, 20.8. So about 20.8 inches. And that makes sense, right? Like our windshield wiper is 24 inches long. So the distance from the bottom is going to be less than that. Okay. Cool. Cool. All right. Example 5. Excuse me. Number 5 says, in example 5, how far, hold on just a second. Don't you guys all wish you were hanging out with me in person? All right. In example 5, how far from the bottom of the windshield are the ends of the wipers if they make a 30-degree angle with the bottom of the windshield? Okay. So what this is asking is, instead of making a 60-degree, what if my windshield wipers went like this and they were 30 degrees? Red and black today, I guess. Nope. So what if they were 30 degrees instead of 60 degrees? Well, guess what? All that hard work that you did solving your triangle up here has not gone to waste, because we're just basically flipping where the longer and the shorter side is. So before we said this is 24 inches. Across from my shorter side is then 12 inches. Well, that's still true, right? And across from my longer side is 12 times the square root of 3 inches. So now if I stop my windshield wipers at 30 degrees, then they're only going to be 12 inches from the bottom of the windshield. All right. Any questions about that? There's 2 more examples, but I think you guys probably have it. I'll just, okay, great. For example, this one, 30, 60, 90, this is the shorter side because it's across from 30. So if this is the shorter side, then my hypotenuse is 2 times that. So 2 times the square root, 2 times 2 square root of 3 is 4 square root of 3. Okay. And this side over here, my longer side, is this times the square root of 3. So it's going to be 2 square root of 3 times square root of 3, which is going to equal 6. So if you were solving number 3, you would get 4 square root of 3 and 6 as your values. Okay. So that is 6-4. I think that's 6-4. What section we were in? Yes, that's 6-4. I want to give you a 10-minute introduction to 6-5 and 6-6. And then we'll talk about those again on Monday. So this is kind of going to be an intro to these next two sections. Give me 30 seconds to take a drink so I don't sound so bad, and I will be right back. Okay. Hopefully I sound a little bit better now. Okay, so we are going to talk about, remember, chapter 7 is all about right triangles. So every triangle that we're talking about is a right triangle. Thankfully, Microsoft Paint has a nice right triangle tool for me. Okay. So we're learning all about right triangles and what we can do with them. So we've got the Pythagorean theorem, which is awesome. Lets us find the sides. We just learned about special right triangles that right off the bat, we don't even have to solve using the Pythagorean theorem because we can just know, oh, it's a 45, 45, 90. So that means that my sides have this specific ratio. The last part of our chapter that we're going to talk about is something that some of you may have heard of and some of you may have not heard of. And that is called the sine, cosine, and tangent of an angle. Okay, so let me write these on here. So we have the sine, the cosine, and the tangent of an angle. Okay, so you might have actually seen these on your calculators. The sine is sin, the cosine is cos, and the tangent is tan. So somewhere on your calculators, your scientific calculators in Desmos, these exist. Okay, and when we talk about these, what these are is a ratio of our sides in relationship to an angle in our triangle. Okay, so let me show you what this is and then kind of talk about it. So say we have some angle over here. Okay, we know this is a right triangle because I used it in Paint. And we have some angle over here that's theta. Okay, that's a common measurement is theta. Okay. If we are talking about, let's talk about the tangent of theta. Okay. The tangent of theta, and let me put some letters on here. A, B, and C. So the tangent of theta is a ratio, which ratio just means fraction, that means A divided by B. Okay, so has anybody seen these before? Tangent, cosine, sine? Maybe. So that's nice that that's a ratio, but let's dig a little bit deeper, okay? Instead of calling these A, B, and C, we're going to talk about how these sides are in relationship to our theta. Okay, so this tangent of theta, or we have, I didn't mean to do that. We have this theta, this angle here, okay? And we have one side that is opposite, okay? we have one, so this is in relationship to theta. We have this side, which is our hypotenuse, right? We know it's our hypotenuse because it's across from the right angle. And then we have this other side over here that's right next to our theta, and that's our adjacent side. I'm totally butchering. That's not how you spell adjacent. Adjacent. I don't know. So we have theta. We have our angle, right? We have an opposite side. We have a hypotenuse and an adjacent. The tangent of any angle is always equal to its opposite side over an adjacent side. Okay, that's always true. The tangent of theta is always equal to the opposite side over the adjacent side. And kind of to build on that, the sine of any angle theta, so the tangent, if I was drawing it on here, okay, there we go. Well, let me go back to the sine. So the sine of any angle is equal to the opposite side over the hypotenuse. It's a ratio of the sides. And the cosine of any angle is equal to the adjacent side over the hypotenuse. All right, so let's actually put some numbers in here so you can see what this would look like. Let's say that our opposite side is 3, our adjacent side is 4, and our hypotenuse is 5. Okay, so excuse me, the tangent of our angle is equal to our opposite side over our adjacent side. So our opposite side is 3, and our adjacent side is 4. The tangent of theta is 3 over 4. The sine of theta is equal to, should write it in a different color. The sine of theta is equal to the opposite over the hypotenuse. So it's equal to 3 over 5. And the cosine of theta is equal to the adjacent over the hypotenuse. So it's equal to 4 over 5. So these are just ratios that describe basically the relationship between two sides in our triangle. And the reason that these are helpful is because if we can find the ratio between two sides, then we can actually figure out what this angle is. So this you don't have to know yet, but this is kind of the end result. If I know that back here, the tangent of my angle theta is 3 over 4, then I can actually use a graphing tool or a scientific calculator to figure out that this angle is 36.9 degrees. 36.9 degrees. Okay, so this is kind of the Y at the end of the rainbow. You don't have to know why yet, but eventually knowing the ratio between either your opposite and adjacent, your opposite and hypotenuse, your adjacent and hypotenuse, eventually is going to let you get to a place where you can figure out what the angle is between those sides. So I wanted to introduce this so you could see it. So Monday, we're going to spend a lot more time with this. The last thing that I wanted to mention, though, is there is a way. So this looks like a lot of words, right? How do I remember tangent, sine, cosine? There's actually a way that I learned way back when to remember this. You can probably ask your parents if they've heard of this before, but it's SOHCAHTOA. And so it's SOHCAHTOA. SOHCAHTOA. So why am I just telling you random words? SOHCAHTOA. So SOHCAHTOA is a way to help you remember the sine, the cosine, and the tangent. The sine, down here, the sine is equal to the opposite over the hypotenuse. The opposite over the hypotenuse. The cosine is equal to the adjacent over the hypotenuse. The adjacent over the hypotenuse. And the tangent is equal to the opposite over the adjacent. So that's your TOA. So SOHCAHTOA is a really good mnemonic. I guess that's a mnemonic. A good way to remember your ratios on your triangle. Because basically it's telling you sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So we'll do a lot more work with this next week. Probably on both calls we'll be working through this because I think it's a super important concept. And I just want to make sure you guys all get that. All right. Sorry that you guys had to listen to me cough today, but hopefully I will be all better by Monday and we have lots of fun doing sine, cosine, and tangent. So thanks for coming. Hopefully technology worked out okay and you were able to see everything. So have a great day, guys.
Bye.
Thanks. Bye.
So I was watching the video you said, I thought it was kind of wise. Hello? Hello?